Hey, good morning. We're going to take a look at 2.1 day one, the derivative and the tangent line problem. So what you should get out of this today is find the slope of a tangent line to a curve at any point, use a limit definition to find the derivative of a function, and understanding the relationship between differentiability and continuity. All right, so the definition of derivatives as a function. This is when you take the limit as h approaches 0 of f of x minus h, or f of x plus h minus f of x, all divided by h. Now you remember that from last year, hopefully. It's called first principles. Or you have the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Now, derivative notation. Those are a couple of different ways that you can represent derivatives. One of those is f prime of x, dy over dx, y prime, derivative of d over dx of f of x, or dx y. So those are just different ways in which you can represent a derivative. Find the equation of the tangent line to the graph of the function at the given point. So the first thing I need to do is I need to find the derivative of my function. So f prime of x is going to equal. Now I take that 2 and bring it down and multiply it by the 3. And I decrease this exponent by 1, so I'm going to end up with 6x. Now my next step is I am going to find f prime of 2. Now the reason I'm finding f prime of 2 is because I want to know what the slope is when x is 2. So that slope is 12. Now I have the slope and I have a point. I'm going to use slope-intercept form because it doesn't specify to use a different form to find the equation of the tangent line. 8 equals 12 times 4 plus b. Oh, I'm sorry. Oh yeah, 4. Okay. A equals 48 plus b. Negative 40 equals b. So my equation of the tangent line is going to be y equals 12x minus 40. Here's another example. First thing I need to do is I need to find the derivative of 2x cubed minus 3x plus 4. When you do that, you get 6x squared minus 3. Now I'm going to find f prime of 1. So f prime of 1 is 3. My slope is 3. So I'm going to take and put 1, 3 into the equation y equals mx plus b. And in this case, b equals 0. So the equation of the tangent line is y equals 3x. Now we have this function of f of x equals 3 plus 1 plus 1 over x plus 2. So the first thing I'm going to do is I'm going to rewrite this as f of x equals 3 plus x plus 2 to the negative first power. It's just easier to find the derivative that way. Now I find the derivative. Bring down to negative 1, rewrite the inside, subtract the exponent by 1. I'm going to rewrite this as negative 1 divided by x plus 2 squared. My next step is I'm going to find out what f prime of 3 is. So negative 1 over 3 plus 2 squared. That is going to equal negative 1 over 25. So that's my slope, right? So now I go ahead and I'm going to put in 3 comma 16/15 in the equation, or 16/5 in the equation y equals mx plus b. So then I'm going to go ahead and change that 16/5 to 80 over 5. And I'm going to add 3 to it. 80 over 25, sorry. So b is going to equal 83 over 25. So my equation is y equals negative 1 over 25 x plus 83 over 25. That's my equation of my tangent line. Excuse me. Excuse me. Okay. Now we have f of x equals the square root of 2 minus x, and the point is set negative 7, 3. I'm going to rewrite that as 2 minus x to the 1/2. Now I'm going to take the derivative of that using the chainsaw rule. The chain rule, bring down to 1/2. Subtract the exponent by 1. Multiply by the derivative of the inside. So this is going to equal negative 1 divided by 2 times 2 minus x to the 1/2 power. The next step is I need to find out what the slope is at negative 7. So I have 1 divided by 2 times 2 minus 7 to the positive 7 to the 1/2. So I have 1 over 2 times 9 to the half. Now you know the square root of 9 is 3, so my slope is going to be 1/6. Now I put in the point negative 7, 3 into y equals mx plus b along with my slope, the slope. Forgot that negative sign. Sorry, so this here should be negative 1/6. So 3 equals 7 over 6 plus b. Therefore, b equals 18 minus 7. It's going to be 11/6. alternative form of derivatives at x equals c is limit as x approaches c of f of x minus f of c, all divided by x minus c. Now use the alternative form to find the derivative of f of x equals 3x squared minus 2x at x equals 1. So that means is that f prime of c equals the limit as x approaches c Now I'm going to take a look at the limit, f prime of 1. Now this is going to equal the limit as x approaches 1 of f of x minus f of 1 divided by x minus 1. Now this equals the limit of x approaches 1 of 3x squared minus 2x minus 1, all divided by x minus 1. Now where did this 1 come from? I just put 1 in right here into the x's. 3 minus 2 gives me 1. So I have 3x squared minus 2x minus 1 all over x minus 1. I'm sure at this point some of you are already going to notice or see what's going to happen. I'm going to factor that numerator. So I have 3x plus 1 times 3 as x minus 1 all divided by x minus 1. Now these x minus 1's to simply divide out. So I take a look at the limit as x approaches 1 of 3x plus 1. This is going to be 3 times 1 plus 1, which is 4, where x cannot equal 1. All right, that is 2.1, day 1. Let me know if you have any questions.